Hey guys, Kaushik here. So today I've got you a lead code question where the question number is 1365 and the question title is how many numbers are lesser than the current number? Well, looking at the title, it is very clear what should be the problem description all about. But then let's just try to understand what exactly it is. So they have given us a integer array, nums, where there are all integer elements, fine, right? Positive elements. And there should be an output array which is again going to be an integer, right? Integer array. Whereas for every element, we do have a respective element, which is nothing but the count of numbers in the array, which is less than the current index. For example, let's take 8, and for the 8, we do have 4 here, which says that there are 4 elements which is less than 8. All right, fine. Continuing with this, you check with 1, there is no element which is less than 1, so it is 0. And for 2, there is only one element which is less than 2. Likewise, there is another 2 which is also one element which is less than 2. And for 3, we do have 3 elements which is 1, 2, and 2, right? So that's 3, right? I hope the question is clear. But the moment you understand the question, the first and foremost logic which strikes our brain is the brute force approach, isn't it? Where you will take a nested for loop. But wait, there is a better solution than that. We'll discuss both, but to understand the optimal solution, watch the video till the end. All right, fine. Now, let's try to understand how does this brute force solution work. Fine. So what do we do for getting this brute force solution done is we will take a nested loop, right? That is, it is going to be I and j. Fine. So we will let me just put my I over here, and I'll start my j also from 0 itself. All right. And I'll also take a count variable where c is equals to 0. Done. And what is my work is very simple. My j is going to iterate towards the array and count number of elements less than I. For example, I take 1. 1 is less than I. Yes. So I increment my count to 1. And again, getting back to again j, I'll try to increment my j. 2 is less than I. So I'll increment my count to 2. Correct. Got the point? Now again I'll check with another 2 which is again less than I. So I'll increment my count to 3. And again I will check with j, and you observe I'll increment my j which is at 3 now, right? Which is less than 8. Yes, I'll increment my count to 4. And this c I will push into my resultant array. Once I have done with this, I'll reset my count to 0 and I'll increment my I value, and my j will again start from 0th index. Again, I'll run throughout the array and I will find, I'm understanding that there is no element less than 1. Thus, my count remains 0. 0 will be pushed back to your resultant array. Then again you will reset your count as 0, increment your I over there and start your j from 0th index and run till the end, right? So that you will figure out there is only one element which is less than 2, which is going to be 1, and you keep on doing the same thing, you get your result in the array, you will return this array, right? That's what the logic is all about. Fine. Let's try to understand how are we going to code it. Fine. Okay. When I'm trying to code this, I will be requiring a resultant list, an empty resultant list, right? And then I'll run a for loop for I in nums, right? So I is going to run for all the elements in the array. Likewise, I'll also go with for j in nums, right? And what is my work is I have to check whether is there any element, that is any element j which is less than I. And if you find an element, if you, let's say j is less than I, my work is very simple, increment the count and do not forget to initialize your count as 0. I am initializing it inside my for loop because for the next iteration, my for loop, my c will become, or my count variable will be reset to 0 again, right? Now, once you are done with the nested for loop, your count will have a value which is the number of elements less than the current value. So what I'll do is I'll push the result right in, I'll push the count value into my result list. I keep doing this process. I come out and I return my array or the list, right? That's all. And if I run the test case, yes, you can see that yes, it is passing all the test case, not a problem. And let me try to submit the code, and yes, it is running, but wait, it is giving me the time complexity as somewhere around 126 ms, and it just beats only 42.84% of people. It means there are better solutions than what we have done. Fine. Let's try to understand the time complexity of whatever we have done, right? So if you observe this very keenly, we did use a nested for loop. Thus, the time complexity is very clear that it is going to be go of n into n, which is a quadratic time complexity, right? But to reduce it, what are all the other time complexities we have, which is less than that? Is it can be big O of n log n, it can be big O of n itself, so on, right? Fine. But let's try to understand how are we going to reduce all of these time complexities. Fine. To understand that, you need to do two things. The first thing is you will have to observe the question more clearly. Generally, people don't look into the constraints of the question. If you see the constraints, you see they have given a very clear data saying that nums of I will be always greater than or equal to 0 or less than or equals to 100, isn't it? Right. In that case, we are very clearly understanding that each and every element in the array will not be more than 100 or less than 0. But why should we bother about it? You will understand it soon. For this, we will go ahead and take another test case. Let's try to understand the program with this test case. You see, in this test case, you can clearly see that there is 8, right? And number of elements less than 8. So what you do is you generally run towards these array, right? You will check with 1, 5, 2, 2, 3, 2. Again, you keep on running towards the entire array and get a value. Now, we will do the same thing for 5, right? We will check, is it 8 less than 5? No. 1 less than 5? Yes. And you will check with 2, 2, 2, 2, 2 again. But you can observe one thing very clearly, that aren't we doing some unwanted iterations over here? For example, let's take 8. To count number of elements less than 8, we are running towards the array. For 5, again we are running. So these 2's are being counted again and again. Can I say that? Right. Instead, imagine I have the frequency of them already. For example, let's say 2, right? What is the frequency of 2? Is very simple. 1, 2, 3, 4, 5, 6, 7, right? 7. The frequency of 2, 7. And all I have to do is I'll just check whether is it my 2 less than 8? Yes. I'll directly add 7 to it, right? To the count. I don't have to run my iteration 7 times. So that saves times. That does save times, isn't it? Right. Let us try to understand how are we going to put all of these logics together and get this done. In that case, I will be taking again a hash array, I can say. I can do it with dictionary, but let me explain with hash array so that people coding in C or C++ or Java would be, it will be helpful for you also, right? So let me take an hash array filled with zeros, but then how many zeros am I supposed to take, right? That idea you would be getting into the constraint part. So here it is very clearly mentioned that they are not going to have elements greater than 100, right? So it is enough if you take 100 zeros. For now, let me just take these zeros for understanding enough, right? Let's also try with the indexing part. Now let's try the indexing part. The indexing is going to be 0, 1, 2, 3, 4, 5, 6, 7, 8, 9 and so on, isn't it? Fine. What is my work is I will run through my iteration, right? Where I'll just take 8 and I'll go to index 8 and increment to 1. I'll again go to 1 and I'll increment the value to 1. I have 5, so I'll go to 5th index and increment to 1. You need to understand what I'm doing over here. You take 2, I'll go to 2nd index and increment it to 1. Again, I have 2, I'll go to my 2nd index and increment it to 1 again. I've got 3, so I'll go to 3rd index, increment it to 1. I'll have to increment it to 2, my bad. I'll go to again 2, 2nd index and increment it to 3. Again 2, I'll make it as 4. Again 2nd index, I'll make it as 5. Again 2nd index, I'll make it as 6. Again 2nd index, I'll make it as 7. And now I'll go to 4th index and I'll make it as 1. Fine. Now, if you observe this hash array, you can understand that it is consisting of the frequency of each and every element we have in the input array, right? But what am I going to do with this? It's very simple. Let's take 8, right? What do we need is number of elements less than 8, isn't it or not? Now you just take 8. Please do not go to 8th index, but then add all the numbers until 8 minus 1, 7th index. If you observe 7, 1, 8, 9, 10, 11. So the sum value is 11, isn't it? There are 11 elements which is less than 8. Likewise, you go to 1, right? You will not go to 1, you will go to 1 1 less than that, 0. What do we have there? 0. So there are 0 numbers less than 1. Now let's go to 5. Right? You go to 5, you will check until 4, sum of all of this. It is 7, 8, 9 and 10. There are 10 elements which is less than 5. Now, I hope you're understanding how did we reduce time to an extent. But then, observe, to add all of these numbers, let's say for 5, we are running from 0 to 4. For 8, we will run from 0 to 7, right? But we can reduce that as well. But how am I going to do it? Is very simple. I am going to convert this hash array which we have just now created to a prefix sum array. That is nothing but all the previous values will be added to the current value. For example, this 0 will be added to this 1, which will remain 1 itself. This 1 will be added to 7, which will become 8. And this 8 will be added to 1, which will become 9. This 9 will be added to the next one, which will become 10. And again, continuing with this, 10 will be added to 1, which will become 11. 11 added to 0 remains 11 itself. 11 added to 0 remains 11 itself. 11 added to 1 will become 12. And this is going to keep on becoming 12 until 100th index, if you remember. Because we have an hash array which is going to go till 100 because of the constraints, right? Now, let me rearrange the indexing properly. This is going to be 2, 3, 4, 5th index, 6th index, 7th index, 8th index, 9th index. But why do we do this? I'll tell you. Just observe, check with 8, right? How many elements are less than 8? 11. And where are you finding this 11? It's at 7. That is 8 minus 1. You will check at 7th index, you will find the number of elements less than 8. Again, let me just go to 5 directly and check, right? The answer should be 10. Let's go to 4th index and check. Yes, the answer is 10. And that's it. You're all clear, right? So, that's it, right? So, for this, you will take n time to find the answer. Instead, the previous time we were running some, right? We were trying to add till 4th index, trying to add till 7th index. We did took time. But we have reduced time over here. Isn't it? So now let's try to put all of this into a code form and let us code it really quick. Now, just observe while coding it, right? Or if you want, you can pause the video over here and try this code for yourself. Yes. And come back again, see whether your logic is right or not. Okay. Now, just check this code. We will take initially two things. One is my result array, an empty list, which is to be returned as an output, and also a hash array. I'll just put it as prefix sum array. So PF equals to, I'll have to have zeros. But how many zeros am I going to have? It is going to be from 0 to 100, isn't it? So I can say I will be requiring 101 zeros in this. All right. Now, running this array for I in nums, I is going to be each and every element in the array. I will have to go to that particular index and increment this value. So I'll put it as plus equal to 1, or I can write it as PF equals to PF of I, the current value plus 1. I have to increment it, right? If it is 1, I'll make it as 2. If it is 3, I'll make it as 4. Done. Once that work is done, we have made this array without the prefix sum, right? Which had 0, 1, 7, 1, 1, all those stuff. Now, continuing with this, I will have to go ahead with another for loop which will run from 1 to 101. But why? We'll discuss. It is going to run from 1 to 101 and it is going to add all the previous values. But how am I going to add all the previous values? Very simple, right? See, if you want to add all the previous values, you will have to write as h of I equals to that current place plus the previous one. So I can say I minus 1. All set, right? So that's how it is going to be. So PF of I equals to PF of I plus PF of I minus 1. All set, right? We have created our array, this hash array, isn't it? That is your prefix sum hash array has been created successfully in the code. Now we need to extract the outputs. Thus, I will write another for loop for I in nums. All right, for I in nums. Now, to the resultant array, what am I going to append is nothing but from the PF, I will not take I should take 1 before. So I'll go for I minus 1 and I will just come out of my for loop and return my result array. right? That's how it is being done. Let me just run the code to check whether it is working for the sample test case or not. Now, you can clearly see that it is working for sample test cases taking 0 ms, all good. But let us try to also check with the hidden test cases. There is a small catch in the code. Let's try to understand that once we see an error in the hidden test cases. Let me submit the code to check what it is. That's when you will be understanding what exactly is hidden. Now, if you look at the hidden test case over here, we have got a wrong answer where for 0, we should have got 0 itself, but we are getting 6. Let's try to understand why. See, what happens in this program is very simple, that as we are working with Python, when it is 0, we are checking with I minus 1, right? So it is 0 minus 1, which is minus 1. Minus 1 as in h of minus 1 is the last element of the array, which is 6. That's how we got 6 appended. So it is a very small condition we need to keep in the for loop, saying that if my I is equal to 0, then simply you go ahead in the RES and you append 0 itself. Else, if it is not 0, that is when we are going to get our work done. Now let's try to submit the code to check whether it is working or not. And yes, it is working, and you can observe that it has given the answer in just 4 ms. And yes, it beats 69% of people in this. All set. That's how the logic is, right? I hope you are clear with what has happened here. We have done hashing plus the prefix sum combined together and got it done. But now let's try to figure out the time complexity for this. Trying to understand the time complexity, I can say that the very basic time complexity for this is nothing but big O of n, as we are creating this hash array, and plus we are performing other 100 iterations for what? For doing a prefix sum of this, right? And again, to extract the answers, we are going for another n. I can just say it is 2n plus 100, just to be more specific. But then, while observing or while comparing with the previous value, so when I was doing it in the previous value, it is n into n. Let us assume I have 5 elements. 5 into 5, it is going to go for somewhere around 25. Whereas in this place, it is going to be 5 plus 100 plus 5, which is 110. The value is bigger. But we did discuss that this is going to be more optimal. Yes, it is going to be more optimal for bigger values. Let us assume that I have 100 elements, right? In that case, 100 into 100, this would run for somewhere around 10,000 times, right? But here, for 100 elements, I am going to have it as 100 plus other 100 iterations plus another 100, which is 300 itself. So yes, eventually, this is more optimal than the brute force approach. Hope you have understood what is the exact point of using my hash and the prefix sum. Try writing the code also in C++ and Java, just the same logic, but you will have to have the syntax will be different, right? Also, leave your doubts or clarifications or any other questions in the comment section below. Hope you all have enjoyed the video. Stay tuned for more such videos. Thank you. Bye bye. Have a good day.